Find the volumes of the solids generated by revolving the regions bounded by the lines and curve. We have this example given function y equals square root of cosine x, and the x bounds from 0 to pi over 2. And y equals 0 and x equals 0. So let's do that. How you do that? Remember the formula. There it will be pi times the integral from a to b r of x squared with respect to x. Let's apply that here. So it will be pi, and our bounds is easy, and it's given easily. X is from 0 to pi over 2. No stumble. To pi over 2. And the given function is cosine, radical cosine x. Radical cosine x, square root of cosine x, and we're going to square it. When we square it, of course, the square root cancel the square power and cosine x left. So this is the function. Actually, we're going to do it. We're going to integrate it. Pi is outside and integrate from 0 to pi over 2 with respect to x. And as you know, what is the integral of cosine x? I hear you. It will be sine x. And we still have pi outside. So this is the result, pi sine x. And our bounds is from 0 to pi over 2. So let's plug it in, pi over 2. So pi times sine of pi over 2, plug it in for x, pi over 2, minus pi sine, plug it in 0 for x this time, and pi sine pi over 2. Pi over 2, it's the same as 90. Sine of 90 is 1. Minus pi times sine of 0 is 0. So 1 times pi is pi. Pi minus 0 is pi. The result will be pi, or it's 3.14. Let's check our work using graphing calculator. Remember, the final result algebraically is 3.14 unit cubed. Let's do that. Use a calculator here. So if you go to y, first before y, make sure that you set your mode and you are in region. Scroll to region, make sure you are in region here, enter, quit, go back to y equals, and then we start to write the function that you're going to integrate. The function that you're going to integrate, which is pi. How we do the pi? Second and pi, and then cosine x, close parentheses, and to find the integral will be second trace, scroll down to 7 or hit 7. The function is graphed, and they tell us what's your lower limit. Lower limit, as you know, is from 0. So 0, enter. And what's upper limit? Upper limit is pi over 2. So second and pi divided by 2, and then enter. The final result, as you see, is clear, and it's 3.14, similar to our work.